Hi folks, today's set of ICP video notes is about how to graph motion using motion maps. In your notes, be sure to write down the steps to creating a motion map and the 3 examples we'll go through at the end. You can physically see motion happening all around you. Based on your experiences in life, you might even be able to guess at how fast an object is going, or be able to predict where it will go next. When it comes to scientific research, however, it's very important to be able to write down your observations and your measurements down in such a way that any other scientist could look at it and understand what you're talking about. So we're going to learn how to do just that today. When graphing motion, one of the most obvious methods is to plot data points on an XY graph. In this case, our y's are positions and the x's are times. This is why we call these graphs position versus time graphs. We often will measure the y-axis in meters and the x-axis in seconds. When we do this, the slope at any point in time on the graph will give us the speed of the object. This should make sense. As you've learned, the slope is the change in y over the change in x. If our y is measured in meters and our x is measured in seconds, then when we find the slope, we get a unit of meters per second. In the next unit in our class, we'll discuss what it's called when an object changes velocity. For now, just think about that change as a change in the slope of a position versus time graph. You can probably look at one of these graphs and guess whether the slope is steeper or shallower at any point in the graph. When the slope is steeper, the object's moving faster, and when it's shallower, the object's moving slower. But there's a much easier way to illustrate the motion of an object and easily be able to see any changes in the velocity. These are called motion maps. On a motion map, we have dots that represent time. Each dot represents exactly 1 second. We place these dots on a number line at different positions that reflect where the object is positioned at that time. Between the dots, we draw arrows or vectors. The bigger the arrow, the larger the distance the object has traveled in a 1 second time slot. In other words, the bigger the vector, the faster the object was going at that point in time. In order to create a motion map, you must first read the word problem. After you've read the word problem, you can use information from the word problem to create a position versus time graph. After you've made this position versus time graph, you need to look at the y-axis and figure out where your highest point is on your position. Once you find that out, you can make a number line, and that'll be the basis for your motion map. That number line should get you to the highest point on your y-axis of the position versus time graph. Your 4th step is to use that graph to find out where the object is when time equals 0. We call this a starting point. You put a dot at that position on the number line. Then you look at your position versus time graph. Follow the graph from t equals 1 until you hit the line. Follow that point over until you see what position the object is at that time. Then draw a dot on your motion map that shows that position. Label this dot t equals 1. Your 6th step is to repeat step 5 until you've run out of time on the x-axis. Your 7th step really goes with step 6. At any point that you're putting these dots, and you notice on the motion map the object either changes direction or it stays resting for a while, you have to start putting your dots on the level above. So just put it in the same position, but above the previous dot. Once you have all of your dots on your motion map, then draw arrows that connect the dots. This will help to illustrate the motion. Do not draw any arrows going up or down, only do left and right.